Hi there. Now for this part of the question, we're asked to find the general solution of the differential equation x times dy dx plus 2y equals 4x squared for 5 marks, and then go on to find the particular solution for which y equals 5 at x equals 1, giving you answer in the form y equals f of x for 2 marks. So if you'd like to have a go at these, I'll just give you a moment to pause the video. When you come back, you might want to fast forward to the final answer or just take your time and see the method. Okay, welcome back then, if you had a go. Well, first of all, I'm just going to copy down the differential equation. X times dy dx then plus 2y equals 4x squared. Now, this particular differential equation starts to have a particular form, a form that you should be familiar with. And I've got it here where we've got dy by dx plus py equals q, where p and q are functions of x. And if you've got a differential equation in that form, then the general solution is given by e to the integral p dx, which we often call an integrating factor, by the way, multiplied by y equals the integral of q e to the integral p dx integrated with respect to x. Now I can see that by dividing throughout by x, I'll create this particular form. So I'm going to divide by x first of all, and if I do that, we end up with therefore dy by dx plus 2 over x times y equals, and if we divide 4x squared by x, we just get 4x. So you can see that it's got this format now where p is a function of x, it's 2 over x, and q is the 4x. So in order to work towards this, I need to work out what the integral of p dx is first of all. So therefore, the integral of p dx is going to be equal to the integral of 2 over x with respect to x. And that is 2 times the natural log of the mod of x. I'll ignore the constant here, we don't tend to put that in. And that means that therefore e to the integral of p dx will be equal to e to the power 2 natural log of the mod of x. Now I can take the 2 up as a power of x, so this becomes e to the power natural log of x squared. And whenever you've got e to a natural log, you always get back what it is that it's operating on, in this case x squared, so this is equal to x squared. This tends to happen quite a lot in questions like this, so you should be familiar with that one as well. Okay, so if we just carry on down here, if we now go to our equation here, we've therefore got e to the integral p dx, which is x squared. So x squared multiplied by y will equal the integral of q, which was 4x, and that's being multiplied by e to the integral p dx, which we've seen as x squared then. So multiply that with x squared, and we integrate all of that with respect to x. So what we've got here then is x squared y equals, and we've got 4x cubed here, so if we integrate this with respect to x, it's going to be 4x to the power 4 over 4, and then plus a constant of integration plus c. And cleaning this up, we've got x squared y then equals x to the power 4, the 4's cancelling, plus c. Now we've got to work out what that constant of integration is, and we've got this condition up here. That is that therefore when x equals 1, we know that y equals 5. And if we substitute this into this equation here, we'll just say sub in 1. Then what we've got is 1 squared, which is 1, times the 5. That's just going to give us 5. So therefore we've got 5 equals 1 to the power 4, which is 1, plus the constant c. So therefore c is equal to 4. So that means then that if we were to substitute that back into equation 1, if we just say therefore sub in 1, we've got the particular solution, which is going to be x squared y equals x to the power 4 plus c, which is now 4. And if we're to give our answer in the form y equals some function of x, just divide through by x squared and we get y equals x to the 4 divided by x squared, which is x squared, plus and then 4 divided by x squared. Alright?